Hello viewers, in today's session we are going to discuss another important form of indefinite integrals, and in this session we are going to discuss indefinite integrals of this type where the integrand is of the form that is x square plus 1 divided by x raised to 4 plus lambda x square plus 1 dx, where lambda belongs to the set of real numbers, right? So here in this class we are going to solve an example related to this form of the indefinite integral, right? So here we can see that the integrand, it has a numerator and denominator. The numerator is a quadratic function of the form x square plus 1, and here also we have x square plus 1, and the denominator is a biquadratic function that is of the form x raised to 4. Here the degree is 4 plus lambda x square plus 1, and here we have x raised to 4 minus 8x square plus 1. And if we compare these two denominators, we can see that the value of lambda is equal to minus 8, and this is clearly it belongs to the set of real numbers. So here we'll see how we can solve these type of indefinite integrals, right? So let us see how we can find out the value of this indefinite integral. So let us call this integral as I, right? Now the first step to solve these kind of indefinite integrals is to divide the numerator and denominator by x square, right? So we have I is equal to x square plus 1 divided by x square, and here we have x raised to 4 minus 8x square plus 1 divided by x square, and here we have dx. So now the this term, that is x square plus 1 over x square, it can be written as 1 plus 1 over x square, and here we have dx. And now if we take this x square to the denominator of these three terms, we'll get x square, then we have minus 8, and then we have 1 over x square, right? So now this integral I can be written as 1 plus 1 over x square dx, and in the denominator we can collect these two terms, that is x square plus 1 over x square, and here we have minus 8, right? So the first step to solve these kind of indefinite integrals is to divide the numerator and the denominator by x square and get the form of the integral I like this. So now the second step is to make use of the method of substitution, right? So here I will take a variable t such that this variable t is a function of x, such that the derivative of t with respect to x gives us 1 plus 1 over x square, right? So in these type of integrands, we make use of this substitution, which is quite common, that is t is equal to x minus 1 over x. So here we assume this substitution, that is t is equal to x minus 1 over x, because when we find out the derivative of t with respect to x, then here we have the derivative of x as 1, and the derivative of 1 over x is minus 1 over x square, and this becomes 1 plus 1 over x square. So now a dt can be written as 1 plus 1 over x square, and here we have dx. So now we can replace this quantity with the dt, right? So this is the appropriate substitution here. So now this integral I is equal to integral, and here we have dt. And now let us take care of the denominator. Now in the denominator we have x square plus 1 over x square. So what we will do, we'll take the square of both sides. So here we have t square, and here we have x minus 1 over x square. And here we'll make use of the identity, that is a minus b square, that is a square minus 2ab plus b square. So here t square is now equal to x square, then we have minus 2 ab. So here we have x and 1 over x, and here we have 1 over x square. So this x and this x get cancelled. So we are now left with here we have x square and minus 2, because x and x get cancelled, and here we have 1 over x square. Now taking minus 2 to the left hand side, we can now write t square plus 2 is equal to x square plus 1 over x square. So now in the denominator we can replace x square plus 1 over x square in terms of t, and this is equal to t square plus 2. So here we'll write t square plus 2, and here we have minus 8. So now this integral takes the simple form, that is dt, and here we have t square, and 2 minus 8 is minus 6, right? So now we can rewrite this integral as dt. Here we have t square, and 6 can be written as square of square root of 6, right? And now this is a standard form in indefinite integrals. So now we can easily find out the indefinite integral of this expression, because here we have a direct result, that is integral dx over say x square minus a square, and this is equal to 1 over 2a. And we have the natural log of we have here absolute value of x minus a, and here we have x plus a, right? And here the variable is t. So now we can write the value of integral I as 1 over 2 times square root of 6, because here the value of a is square root of 6, and here we have a log of x minus a, that is t minus square root of 6, and here we have t plus square root of 6, right? And c is the constant of integration. So now let us replace this t by x minus 1 over x, because in the beginning we have assumed that t is equal to x minus 1 over x. So we have I is equal to 1 over 2 times square root of 6, and then we have log. Here t is x minus 1 over x. Here we have minus root 6, and in the denominator we have x minus 1 over x plus square root of 6, and c is the constant of integration. Now simplifying the numerator and denominator, we can now write I is equal to 1 over 2 times square root of 6, and here we have log of x square, and here we have minus 1, and then we have minus x root 6 divided by x, and then here we have x square minus 1, and here we have plus x root 6 over x, right? And Now we can rewrite it as 1 over 2 times square root of 6, and we have log, and this is here x and x get cancelled, so we have x square minus x root 6 minus 1 divided by x square plus x root 6 minus 1, and c is the constant of integration. So now the required value of this integral I is given by I is equal to 1 over 2 root 6, and here this log may be written as ln. Here we can also write the base as e, and here we have x square minus x root 6 minus 1 divided by x square plus x root 6 minus 1, and c is the constant of integration, right? So this is the required value of this integral.